Okay.
So, uh, from the last session, we are let me not this one.
We have seen the ML flow, right? Statistics, and we apply different kind of matrices, R2 and R2 score, and what else about it?
R2 oh yeah, let me
Yeah.
damn.
I am slowly learning statistics actually, like YouTube. I'm going some videos to
No,
understand.
it's no need for it.
But for it, okay.
Yeah, like if statistics is not a like big deal. You have to focus on heavily focusing on LLM.
Okay,
We
okay,
maybe in next couple of weeks we are entering into LLM.
okay, okay.
So this is our notebook. We are basically we are like building the model
Okay.
using without building the model without using ML flow. Then we are using ML flow to perform all the experimentation tracking, parameter tracking, all the
Yeah.
stuff, metrics tracking to track the model to maintain the versions, to maintain the version controls. Even
Okay.
we are also tracking the data sets, all the parameters, yeah, tags like that. You have any doubt till now?
No, no, I'm good actually.
Yeah, we
Yeah.
can also like train uh, more models. Till now we
Okay.
are training lasso, linear regression, random forest, SVR. What we can do, we can also train the. Let me first rerun the notebook. All.
There are how many algorithms are there for machine learning? Rajdeep?
There is a lot of algorithm, lot maybe a hundred or more than that.
Okay. What are the famous ones? These are like these 15 or 21, right?
Yeah,
You said.
yeah. Famous are linear regression and lasso. Lasso is not famous. Linear regression and yeah, random forest is very famous. Random forest, then XGBoost,
Okay. Okay.
AdaBoost, and
Okay.
pooling, voting
Okay.
algorithm, something like that.
Okay.
This was the algorithm, but if you are working on the real world project, you design the algorithm according to your requirement. You little bit tone it.
Okay.
White break, cannot find next
Can
one.
you make it a little bit bigger?
Yeah, sure.
Thank
How is it?
you. It's good.
The last size. Done. So I am one of the worst algorithm is SVR,
Okay.
SVM, support vector machine, because they try to in like what support vector machine will be good in classification problem. Like if you are using the regression problem, what they do, they try to like separate the things, but
Okay.
we have a continuous data, not a like classified data
Okay.
to classify it, so that's why it's perform worse. Its accuracy will be minus. So what we can do, we can try the uh, decision tree
Okay.
from sklearn dot tree for decision tree regressor. Like once you able to train one data set, one model, and the other all the model will be same for you. Just have to change the input settings and paste it here.
Okay.
Everything will be same. So we can change it. Done. Then we can directly also increasing this size. Directly seeing on the UI side. So the UI code will be ml flow UI hyphen hyphen backend of store URI. What is the code? Yeah. So yeah, this was our session we have just run, and this was last time we run it.
Right.
And
Right.
yeah, like Oh, this was the different one. Yeah, this was the session we run just now, and this was the session we run is last time.
Yeah.
This was the I am doing some experimentation before the session.
Okay.
So, uh, hey, you are able to see the accuracy. Let me increase the size also here.
Okay.
Like there is accuracy. Like the accuracy will be going into minus, and that algorithm will be like uh, this one. The algorithm will be like support vector machine. If we go inside here,
Okay.
we see the parameter. What we can do, we can also add one tag also or one parameter also to distinguish between the models.
Okay.
So basically what we can do, we can just directly copy the name and write models model name and give the model name.
Okay.
Lasso same goes to the for all of them. All of it. This one is linear regression, and this one is random forest, and this one is SVR, and oh we train oh decision tree. Just yeah. So after going back to here, we got it. Now we
Okay.
can easily catch the model, like we got the accuracy minus in minus. So what we can do, directly click it, we can you can get the model name here SVR
Okay.
inside the parameters.
Yeah.
So this was the basic dashboard. It will help you to easily like get it, what model is giving the good accuracy or what model is performing worse.
Okay.
Yeah, so like you can also perform the comparison by selecting all, perform the comparison. It will do the SVR.
Okay.
The SVR
Okay.
accuracy will be like going down, and the random forest accuracy will be increasing, and yeah, linear is also increasing, lasso is
Okay.
increasing, decision tree is also increasing,
Okay.
but it's going very worse.
Okay.
And what is this model, this maintaining the constant, we have to check it once. So, or you can also able to see it in the shutter plot by adding the model name and the auto score. This was the SVM which is on minus, and the decision tree and the random forest. We can
Okay.
easily tell that the random forest will perform well, and the second one will be like linear regression, and the third better is lasso, fourth better is decision tree, and the worst is SVM
Okay.
by seeing the visualization. And same
Okay.
goes to the box plot here by selecting the model name and the score. It will show you which is performing good, which is performing well, and also the contour plot is why not showing. They're just giving the graph, so ignore it for now. Yeah, do you have any doubt from this UI board
Um. No,
dashboard?
Javid. That is so far I'm good at.
So far you can understand it.
Yeah. Yeah.
None-
Yeah. Initially, when I attended Fatima classes, it was like hard to understand. But now I'm going through second time, right? Like some of the things.
yeah,
Now I'm trying to make sense of it. Like, I get that.
yeah. Sometime it will. Yeah, this thing need practice basically.
Yeah, practice. Yeah, after she told like it was. I mean, all these mathematical stuff, right? I was reading here and there little bit, and now whenever retelling everything, I mean, some of the patterns, then I'm making connections out of it.
Yeah.
Yeah,
Now you can easily like tackle it by like those were the SVR and the accuracy and the name.
yeah,
All
yes,
thanks to parameter log parameters.
yeah.
So we are where is our notebook? Yeah, we are done with the basic logging thing, like basic model tracking, model experimentation. This was
Okay,
the model tracking, and this was the like experimentation we are doing here.
Okay,
by
okay,
comparing all of them,
okay,
by comparing all of them by so this was experimentation part.
okay,
In ML flow, basically two things here, two main things ML flow. One of is experimentation, and another one is models, which will be I will tell you in next couple of days or maybe tomorrow.
okay,
What is it? So for today, we are focusing on in model tracking and experimentation. We are done with the basic model tracking and basic experimentation. In machine learning, like you got the accuracy of 70%. But if you want to increase the more accuracy, then what you have to do, you have to like by giving currently I give the alpha value will be 0.1 to the lesser one.
okay,
Where is it, yeah, so I got the 0.1 to get the accuracy like 74%. Like I will I change the value and change the value and randomly giving different values, and it will increase the accuracy and decrease the accuracy.
okay,
So this will be very hectic if you like if you're giving manually one, if you're giving manually 1 2 3 4 5 like. So for that what we have another concept called hyperparameter tuning. We just have to predefine some values, then train it. It will automatically train all of them
okay,
and give you the best result. Which parameter will give you the best result? They only show you the best result.
okay,
Like I gave the parameter like in hyperparameter tuning. What I give currently, I give the value of 0.1. So what I give the one big range. I want to be the train the hyperparameter value like 0.1 to 0.9.
okay,
So it
okay,
will iterate from 0.1 to 0.9, and I figure out 0.6 will be performing well, so it will give you the 0.6 accuracy,
okay,
0.6 parameter model accuracy.
okay, okay,
Basically what they do, they performing inside algorithm. What they are doing, uh, they performing from 0.1 to 0.9, running all the
okay,
thing, then we got all the accuracy. Then what they do after getting all the accuracy, they pick the max value,
okay,
simple, or they doing the ascending order and take the top one.
okay,
Like the reason why I tell you all this in depth detail, you can also in future you can also uh, write your own custom metrics, custom algorithm.
okay, okay.
So we are starting here for hyper parameter tuning. And whatever the code I read, you don't need to you don't need to revise it or you don't need to by heart it. Everything will be taken from the documentation
Got it. Okay,
or
okay,
taken from the chat GPT or taken from the Stack Overflow. We just have
okay.
to remember the concept,
Understood.
what thing you're using where. Simple. For hyperparameter tuning, we have a very famous library called HyperOpt.
Okay,
HyperOpt, hyper, hyper OPTS. Yeah, HyperOpt. This one. Yeah, this was the very popular library for performing the hyperparameter tuning. There is a lot of library to perform to do it the task. We
okay,
can also perform the hyperparameter tuning using the scikit-learn. But
okay,
this is
okay,
the better thing. They give the lot of option because this library is basically built only for the hyperparameter tuning.
okay, okay,
Scikit-learn library is the umbrella of all the machine learning stuff.
okay,
So you can directly come to the documentation if you want to read about the library documentation and read it, or directly come to the documentation.
okay,
And one more thing, you don't need to revise or see all of them. You just directly come to the library name and come to documentation and
okay,
what what framework you are using. You are using the scikit-learn or you are using the Spark.
okay.
Like if you are working on the very big data, like you're working on the data engineering side, big data side, then you won't work on, you won't use machine scikit-learn library. You use Spark.
Right. Okay,
In Spark we also have
okay,
Spark ML.
okay.
Spark
Yeah.
ML, yeah, Spark ML. With the help of Spark ML, you can build the machine learning models. So I
Okay.
select
Does
the
Spark use SQL
yeah,
or like it's a completely different?
which one?
Does Spark use
Yeah,
no, actually, does Spark use generally SQL or like it's completely different?
your voice is breaking. Can you repeat it, please?
Oh, so my question is like, does Spark ML use internally sklearn or like it has completely different implementation?
You can say it's internally they're using sklearn but more optimized version. They write it on sklearn.
Uh, on top of it, SQL, they made it like, better
Yeah,
version out of it.
yeah,
Okay.
yeah. Basically, Spark have two to three extension. Like one extension is Spark SQL, another one is
Okay.
Spark PySpark, another one is Spark Streaming, another one is Spark ML.
Okay, man. Okay. Okay.
Yeah, it's
Okay.
four to five types here. So the more
Okay.
popular is Spark SQL and Spark PySpark or Spark
Okay.
Streaming.
Okay.
Spark Streaming so used
Okay.
to Kafka to fetch the streaming data.
Okay. Okay.
Spark ML only use the data scientist.
Okay.
So I come to the documentation, then I come to the uh, hyper of scikit-learn and open the different pages. So they give me the, yeah, how can you use the Spark, like how can you use the hyperopt.
Okay.
This was the library. Like if you don't understand anything, directly come to the chat GPT and ask and tell me I want a code to perform the hyperparameter tuning, and it will give you the code.
Okay. Okay.
So I basically already write the code because the Spark yeah, hyperparameter tuning code is little bit big. It's all about experimentation. You have to give a day
Okay.
or two to write the like hyperparameter tuning code to understand which one is better for you.
Okay. Okay.
You have to write all the parameters. So
Okay.
I directly copy it from one of my notebook to save the time.
Okay.
But before we have to install the hyperop library also.
Okay.
Yeah, it's done.
Okay.
Can complete down. So yeah, this like we are using XGBoost.
Okay.
Till now we won't using XGBoost in our normal coding. Like in here we won't use the XGBoost, but now we can use XGBoost to get the accuracy. And
Okay.
XGBoost is one of the model that can perform. You can like blindly say XGBoost is working well on any data set.
Okay.
We can also what we can do before hyperparameter tuning, we can also perform the XGBoost on our
Okay.
normal code without hyperparameter tuning. So I take XGBoost and XGBoost dot I want XGBoost regressor and hold the value in some variable.
Okay.
Then after that xg dot simple fit and give the x and y, and whatever the value we got, we just copy here. Everything will be same, you just have to change the
Okay.
first just change the model name and the in class. Oh, we got the R2 of it give us 78%.
Okay.
So what we can do, we can directly put into the ML flow. So ML flow will be like very simple. With ML flow dot start run and take all of them inside here
Okay.
and directly copy it from here to save the time. And give the model name will be XGBoost regressor, and what is it left, model accuracy
Okay.
matrix. Now we got the UI here. It give the pop-up of refresh. Once we refresh, we got the model of, why it won't show the name, let me, yeah, XGBoost. So
Okay.
it gives 78% accuracy, and the SVR is worse. Decision tree gives 67, random forest gives 82, linear 76 and the 76. And
Okay.
after XGBoost, there is a two to three very good algorithm in machine learning performing well. First one is XGBoost and another one is gradient boosting,
Okay.
and another one is AdaBoost.
Okay. Okay.
Like XGBoost, gradient boost, AdaBoost,
Okay.
random forest, sometime linear regression.
Okay. Okay.
This was the 4 to 5 algorithm which is performing very well. I can also like write the code here from they directly come from scikit learn dot ensemble
Okay.
import AdaBoost regressor. So directly give the AdaBoost to this one. Ada got the AdaBoost. So AdaBoost give also same 78%. Yeah, AdaBoost is also performing well. It's also performing the same
Okay.
AdaBoost. So
Okay.
what left? Another one is gradient
Okay.
gradient regressor. Or what you can build one function on top of it. Just pass the parameter of the model name and the model name and directly it will run it. Have you understand what I'm trying to say? Put all the thing in the function and give the parameter of the mo- model name
Okay.
and will reflect everywhere
Okay. Okay.
and directly print it instead of writing all of the code again and again and again.
Okay. Right.
GB GB. Oh, the reason why it's giving because we won't change here. We also have to
Okay.
change here. Now let's see the AdaBoost gradient boosting. So let's refresh it. Yeah, AdaBoost. Yeah, this one is also the XGBoost. Sorry, AdaBoost. And this
Okay.
one is no, this one is XGBoost. So this one is AdaBoost, and this one is gradient boosting.
Okay.
So in here we can say that gradient boosting is performing well, but also you also have to taken care of the time. How much time it's taking? It's take
Okay.
130 millisecond.
Okay.
And what about the other model? They give the second good accuracy. It gave 47.
Okay.
Time is also matter because in real world you won't train data on 100 or 200 or 1000 rows. You train model on like lakh or
Yes.
million rows.
Yeah.
So
Okay.
for that you also have to take care of the space and take care of
Okay.
the time,
Okay.
basically time and space complexity.
Okay.
And this one is taking lot time. So we can say for our observation we can say AdaBoost is performing well because it's giving the 82% accuracy in 47 millisecond
Okay.
duration. Others are taking these good ones are taking 130 millisecond,
Okay.
and the second good are taking third good are taking 119, but the AdaBoost are 47.
Oh, it's very nice.
Understand this like time and space complexity.
Okay.
So what left? We are done AdaBoost, XGBoost, gradient boost. Now we can also directly jump into the hyperparameter tuning. So we are doing
Okay.
hyperparameter tuning on the model of XGBoost to
Okay.
increase the accuracy. So
Okay.
this was the like we have to import some classes directly from the hyperparameter tuning. Then after that, I directly copy it. Then I will explain you.
Okay.
I want R2. Yeah. Basically, we are taking the data of x and y and
Okay.
giving like x-train, y-train, and x-train, y-test. For training the data set, we are giving x-train, y-train. For validating, like basically testing it. So
Okay.
we're giving the data set x test, y test, and This hyperopt support function, they take this hyperopt library. What they do, they accept the function.
Okay.
So the function is basically this one, objective. In argument they take the parameters, then everything will be same. What this objective function do, they taking the arguments of parameters. The
Okay.
parameter will be this one.
Okay.
So what I do, I like I start the ML flow and set the parameters of model is equal to XGBoost.
Okay.
Can also give model name hyper XGBoost, and whatever the parameter we take, we can also log the parameters here. Then after that, we train the XGBoost dot train, and pass the parameters and pass the data set, and also giving the round how many iteration you have to perform it.
Okay.
Basically loop run 1 2 3 200 to 2000. After running the 1000, we can also perform, also giving the test data set to
Okay.
evaluate an early stop around 50 means like uh, it after certain iteration, like after certain iteration, maybe example like after 160 iteration, you got the accuracy of 84 into 50 times. So what they do, they automatically stop it instead of going to the 1000. Basically it's
Okay.
a waste of time and a waste of resources. If you got the same accuracy, same result, then why don't you stop it early instead of go waiting for the end.
Okay.
Like I got the better accuracy in 20 iteration.
Oh, okay. Okay. So you were saying like after 50 iteration, it gets the better results, it will stop.
Yeah, what they
How
do.
does it? It's getting better results. Maybe let's say it is getting 99.7, but still it is thinking like 100 will be the best result, right?
Yeah, it's all about experimentation. I will
Okay.
show you, I will just show you the example of it.
Okay.
Yeah, it's all about experimentation.
Okay. Okay.
Like if I got if I got the best result in 20 accuracy, so in
Okay.
20 iteration, so I
Okay.
don't need to go further. If I go further, I get the less accuracy. Then like
Okay.
that, I check onto 50 times.
Okay. Okay.
If I get
Okay.
the same accuracy on the 50 round, next 50 round, then I honestly just break the loop. Basically, break the loop. I don't want to go further to waste the resources, to waste the time, to waste the
Understand.
consumption.
Okay. Okay.
So that's why this early stop. Basically, the early stop, the future will introduce on deep learning frameworks. Then it will also
Okay.
come to the machine learning.
Got it. Okay.
Then
Okay.
after that, I am also predicting it. After training the
Okay.
model, also predicting it and performing the auto score.
Okay. Okay.
Auto
Got it.
score not need this one. Yeah. And whatever the R2 score I got it, I log it
Okay.
and return in the form of dictionary. Loss is equal to R2 score. Instead of write, I
Okay.
write R2 score, and status okay means successfully run.
Okay.
So I run this function, and after that, this was the parameter
Okay.
in depth learning, max depth when we have to go learning rates. Basically value from -1 -3.1.
Okay.
Let's see, exponential of -3. For that I have to import the basically exponential of -3.
Yeah.
Then alpha, lambda, children, blah blah. Why we are using linear? Because we are working on the regression dataset.
Okay. Okay.
If you are working on the like classification dataset, then you have to give the different classification is equal to this one.
Okay.
Now whatever the value we have, I directly pass it to here.
Okay.
F in function, I directly import it from the hyperopt,
Okay.
and
Okay.
inside Fin they in Fin utility we import from the hyperopt. First they accept the function. First
Okay.
parameter is function, so that's the function which we write it here. Directly pass the function and directly pass the parameter of it. Then the
Okay.
suggestions, then the like evaluation matrix and the trial. Just try it.
Okay.
So once I run it, it will why it's failed. Train is not defined. So okay. Oh, I don't run this one. I just run here. Yeah, it's training.
Okay.
cannot access local R2 where is associated with it. Oh, basically it's giving RMSE score.
Okay.
I want can do we can from sk learn dot matrices import RMSE score and model name hyperopt white sphere again. Yeah, it's iterating.
Okay.
So it takes some time. So I will directly go to the top here. Yeah, in first iteration they take 1 to 50,
Okay.
then second iteration they take 1 to 50 again, then third iteration they'll take 1 to 50,
Okay.
just like 1000 times. But in between they got the better accuracy and the result will won't increase, then it will break it.
Okay. Okay.
Same thing happening here. It will take time.
It stop middle like 32. Okay.
I think it's running. Let me go down. Yeah, it stopped here.
Okay.
Yeah, it stopped.
Okay.
If we go to the scrollable event, yeah, it stopped because we got after this iteration our loss won't be decreased.
Okay.
That's why it stopped.
Okay. Okay.
If the loss will be decreased, then it won't stop. So let me
Okay.
see the first loss. What is it? Our loss started from 21,636. Have you able to see this number? Oh, sorry, this one.
Now,
Nine,
yeah.
90,
Nah,
93, 9387.
correct. Yeah. Yeah.
Yeah. Now it will decrease the loss is equal to is to like uh, 30. Is this one
Okay.
484812.
Okay.
But here the loss will be like it will maintain the after coming from the 4 rate 4000 basically, then it will again increase the loss. So
Okay.
that does not mean that does not make any sense. While you are training the model, it will suddenly it will decrease the accuracy, then it is increase if you increase the iteration, changing the values.
Okay.
So that won't help for us. We have to choose the better parameters, better which parameter is better, so that we can use the parameters on the production.
Okay. Okay.
Yeah. Have you
Got it.
understand this hyperparameter tuning?
Yeah. Yeah. Understand that. Yeah.
Any dot
No. No. I'm good actually. Yeah.
we can also like train the others model if you want.
Okay. I'm okay actually. Yeah. I understand the concept.
Same like if you want to train the different model, just copy the code, paste it on
Okay.
down, and instead of taking XGBoost, take
Okay.
the different one like gradient boost or ADA boost
Okay.
or
Okay.
random forest, or you directly instead of taking here or directly come to the Google,
Okay.
right?
Okay.
Random forest hyperparameter scikit-learn.
Okay.
This one it will give you the this tuning
Okay.
code random forest
Okay.
regressor.
Okay.
Why it won't give the sample code? Yeah, you can find it from here. Yeah, directly copy the code from here and change it according to your requirement and
Okay.
train the model.
Okay.
Yeah, you don't need to do any extra stuff by
Okay.
writing the code from your side from scratch.
Okay. Okay.
Yeah, we got the coded here also,
Okay.
and this was trained. Oh, you have to take it this one.
Okay.
Then no, you have to take it this one and pass it to the model. Then we get the accuracy, and basically the accuracy is from the classification model. it won't use for us.
Okay.
We just have to tweak it little bit to our requirement.
Okay.
So for this session, you have any doubt?
No, no, no. I'm good, man. Yeah, go ahead.
Good. So no doubt.
Yeah, no, no.
Yeah.
I think Adam also explained hyperparameter.
Yeah.
Uh, yeah. Now that I'm listening second time, like it makes more sense to me.
Yeah.
By the time I had trouble like understanding the statistics terminology and
Yeah. Your voice is breaking now. Again.
oh, it's taking. So how is it now?
Which one?
How is my voice now?
Yeah, it's now fine.
Yeah, yeah, yeah. By the time I have trouble understanding the terminology what she was using, and now I'm understanding after attending all the sessions, and now when you are talking it's
Yeah.
making sense to me, like when you are going through again.
Yeah. First time this technology will be a little bit difficult to understand.
Yeah, yeah. All right.
It's a pure mathematics statistics thing. You should have to thanks to the scikit-learn and the other libraries. If the libraries
Yeah,
won't come, then we have to write all the algorithms code
yeah, yeah. Right, right.
from your
Actually,
side.
I spent some time on learning statistics videos for at least
Yeah.
5 hours. Now it is making more sense to me.
Yeah. You can take the classes from directly Khan Academy
Oh, okay, okay.
for
Yeah, sure, man.
statistics and linear algebra.
Oh, okay.
Uh, heavily focus on statistics, probability statistics. It's very easy. I
Okay,
yeah, inferential statistics and discrete. Discrete is easy. Inferential will take time because
okay,
hypo like hypothesis also include
okay, okay,
in inferential. Then you have probability. Then after probability you have calculus, linear algebra.
okay. How many hours of training I should take for calculus and linear algebra? How much time it will take?
No, no, just one 2 hour is enough. There is a
Oh,
YouTube
what?
channel. I want something. I forget it. I will share the video.
Yeah,
Very famous
it's
YouTube channel.
okay,
People.
okay,
I think something I blind eye something here. I will have to check
okay, okay.
once. This
Yeah,
was the if you want to learn the calculus, linear algebra, statistics. This was one of the best channel.
okay,
Even the one of the Andrew Ng and the big AI gods, machine learning gods. They also suggest these channels to learn
oh,
linear
okay,
algebra,
okay.
to learn the
I was
statistics.
actually going to this guy actually Satyajit. I don't know if you know ever
Which one?
Satyajit. His name is Satyajit actually. Though I'm just going through his statistics classes. He does the machine learning and ML in YouTube.
Okay.
Uh,
Yeah, I learn statistics all the stuff after learning machine learning algorithm.
oh, okay, okay.
Yeah, after learning or even between. Because if you taken yeah, if you directly start learning start statistics and calculus, it will what it will do. It will go bouncer to you, and
I'm sorry.
you lose the confidence. If you
Yeah,
directly start to the statistics and machine learning, all the statistics and the calculus thing, you lose the confidence. So for that,
yeah,
I
yeah.
after Python, I directly jump into NumPy pandas on my
Oh,
learning
okay,
phase,
okay.
then machine learning, then deep
Okay.
learning, then I go back again.
Right, right. Okay. Yeah, yeah. It's all about revision, right? Like now, the
Yeah,
first time we don't get anything, like we have to keep going back.
yeah,
Yeah. Now after completing Fatma's class, I spent some time on statistics actually.
yeah, yeah.
Right, yeah.
Statistics it good, but you don't waste too much time on that.
Okay.
Yeah,
Yeah, yeah. Sure. Man.
if you want to do you if you as a senior you have to work more on hypothesis side, A/B testing.
Okay, okay.
You have to run the
Got it.
hypothesis for
Okay.
A/B testing. You have to inferential statistic
Okay,
basically.
okay.
You
Okay,
have to
okay.
learn this stuff.
Oh, okay, okay.
And after that we can take MLOps in another 1 to 2 sessions.
Okay.
1 to 2 weeks. Then after that we are jumping into the once we deploy our machine learning model in AWS, then using MLOps or DevOps practice,
Okay.
then we can directly jump into LLM, NLP,
LLMs.
NLP, natural language processing,
Okay.
then deep learning RNN,
Okay.
then LLM, transformers, then LLM. They
Got
are
it.
all the building blocks.
Understand. Sure,
Yeah.
sure. Okay, okay.
So, so then we can, if you don't have dot, then we can connect tomorrow.
Yeah, yeah. Sure, man. Yeah.
Sure.
Good answer. Thank
Sure.
you.
Thank you.